This is the DC motor control project. This is the DC motor, obviously. This switch here, it changes the direction. So right now it's on reverse. When I go like that, just flip to forward. And when I do it like that, it'll break up like that and go to reverse. These buttons here, they control the PWM. So this one is 50 PWM. It puts it to 50, which is the slow button, basically slowing it to a stop. Then it will start to zoom to 127, as you can see here when this button is pressed. And eventually, if you want to make it go very fast, a fast button, it will go to 200. Now, these are all reflected on this LCD display. As you can see, I just changed it back to 127. The PWM went to 127, and it's saying it's in reverse right now. You can flip the switch. Now it's saying in forward. And I changed it to 50. And finally, I can use the brake. I'll say brake if you can see that. PWM 50 because it's slow to a stop. And I can turn it back on from brake. And it will remain like this for a second. Yeah. And it will go to forward, as you can see, and 127 PWM. Okay, so this is a review of everything in the project. The first part is, and the most important part, is the SN7544, which is this chip. This controls motor direction, gives output, PWM signaling, all of that. It controls the motor for this project. Then we have these two switches here. This one controls direction, so it's flipped like this, it's going to be reverse. Flick like that, it's going to be forward. This one controls whether it's on or braking. Brake basically means stopping in this sense. Then these three buttons here, these are the PWM signals. They tell what the PWM size. This one is the slow button, which goes to 50 PWM. This one is the medium button, goes to 127. This one is the fast button, which goes to 200. Then finally we have the LCD display here. So saying direction and the PWM at the time. And this is the wiring. This orange wire sends a signal, the PWM, and gathers how much power it should give to the motor. This is the motor input. These are both connected to ground. And the grey wire and the red wire serve as connections. The first part of my code is the initialization. Here I initialize the pins for the chip, such as the speed pin, which controls PWM, the motor 1A pin, which sends data to the first side of the motor, and the motor 2A pin, which sends information to the second side of the motor, thus the output to the DC motor. I also declare the pins for the switching, the direction switching, which is dear switch. And then I set the speeds for the different PWM. So the slow speed for the DC motor is 50 PWM, medium speed is 127, and fast is 200. Then I move on to the output, where I initialize the LCD display and initialize all the pins for the chip. Finally, I test each switch for direction and for braking. If it's motor 1A pin low and motor 2A pin high, then that means it's going forward. If it's motor 1A pin high and motor 2A pin low, then it's going in reverse. And if both are low, that means it's braking. Finally, I test each button to see which speed is going. So the first one is fast, then slow, then medium. And it sets the speed value motor 1, which is the variable for the PWM, to one of these. And then finally, I set an analog write the speed pin to whatever speed is determined by the buttons. And then I LCD.print the PWM and the direction.